So we're going to continue looking at words, at solving quadratics in context. So go ahead and pull up a calculator. So again, go to desmos.com/practice. Click on choose assessment, Georgia milestone, start practice. Your calculator is set up. Let's go ahead and answer these two word problems just to show you like how to answer it if they ask it to you in context. So it says, suppose a projectile is launched from a tower. Okay, so anytime, you know, you're talking about anything in context, you want to go ahead and start drawing in whatever it is that they're talking about. So they're saying a projectile is launched from a tower into the air. So, you know, into the air, something like that. Okay, so there it is. With an initial velocity of 48 feet per second. All right, so I need that number at some point. Its height, h, in feet above the ground. Okay, so the height above the ground is modeled by the equation. So -16 t squared. This is the height. -16 t squared plus v initial velocity, which we know the initial velocity is what, 48. So plus 48t. Was it plus or minus? Yeah, plus, and then plus 64. Okay, so where t is times in seconds since the projectile was launched, and since the projectile was launched, and VO is its initial velocity. So VO right here is initial velocity, and we know initial velocity is 48 feet. So I went ahead and put it in. All right, I'm going to go ahead and type it in the calculator just because I already know I'm going to have to solve this in some way, form, or fashion. So shift, oh, actually, sorry, -16t shift 6 squared plus 48t plus 64. And you might have to put, because it's t, I'm going to put y equals, or you can actually put h equals. There you go. So since we're using h equals. All right, so now I'll answer the questions. It says, what tower platform height was the projectile launched from? All right, so automatically, I always know that if my equation is in standard form, the number over there by itself is my initial height. Okay, so what does that mean? That means that it was launched from a tower that was 64 feet high. Okay, so I can already answer that question. So what was the height it was launched from? 64, and make sure you put in the units, so feet. Okay, so number by itself is always your initial. And if you don't believe me, since I've gone ahead and drawn it in, we can go and take a look at it. Where does it intersect the y-axis? Now you see it gets really close, so we're gonna do this so that we can really see, and you can see that it meets it at 64. Okay, so the number by itself, C, is always your y-intercept or your initial. All right, how long was a projectile in the air? Okay, so that means I want to know how long was, so it went up. So the projectile went up and then came back down, and the time that it took, so from here, from 0 to some number here. Okay, so remember, whenever you're solving a quadratic, so if I put it equal to 0, where the height is equal to 0, because at this point, right, where it hits the ground, the height is going to be 0 because it came from the tower all the way to the ground, 0. So if I go and look at where it crosses the x-axis, it's going to be my how long it took. So I go to the x-axis, and if you just click in there and then go right here, it's 4. So this right here is 4. Now, if you zoom in a little bit, you'll see that at 0, it wasn't on the ground, right? Because at 0, we just looked, when we looked a few minutes ago, it was at 64. All right, so it hits the ground 4 seconds later. All right, so 4 seconds. How long was it in the air? 4 seconds. All right, when did it reach the maximum height? Where's the maximum height? This point right here. So again, you just come to the graph, you click in here, and you put your mouse. The first number is your x value, the second number is your y value. So my height is 100, okay? So when did it reach its maximum height? When, so that has to be the time. So what was the time when it reached its maximum height? 1.5 seconds. So my x value, which is t, 1.5 seconds. Okay, what was the maximum height? 100 feet. Okay, what domain makes sense for this function? So remember, domain is your x, okay? So again, even though On paper, we see this graph goes on forever. In real life, it doesn't do that because in real life, you can't have negative time, right? So what domain makes sense from the time I started, which was my initial time, which was 0, right? Because I'm looking at my X values, to 4 seconds. There was a graph from 0 to 4 seconds. So write in your domain. So you do interval, closed interval, because it includes 0 and it goes up to 4 seconds. Closed interval because it includes those numbers. Okay, so you can see word problems are really, really, really simple. You can just put it in the calculator and use the calculator to solve your problems. All right, so we'll take a look at this last example. So here's the function. Divided by h equals 5 plus 60t minus 60t squared. And it gives the height in feet over a cannonball. All right, so here's a cannonball, or what I imagine a cannonball to look like. And it shoots, and the ball falls, or the bomb, or whatever it is. Then there's a big explosion over here. All right, cool. All right, the height of the cannonball after the ball leaves the cannon. All right, what does the 5 tell us about the cannonball? So what does this number here tell us about the cannonball? All right, so remember the one that's not attached to a variable is the initial height. All right, so what that's telling us is that this cannonball is fired from a height of 5. So this height, because I guess it's not entirely on the floor, right? So this distance here is 5. So what does the terms 5 tell us about the cannonball? And go ahead and write it because mine will look like really bad. Just write it represents the initial height the cannonball was shot from. So I'll say that again. It represents the initial height the cannonball was shot from. All right, number 2, use graphing technology to graph the function. All right, so go ahead and put it in your graphing calculator. I'm just going to use the previous example and change the numbers. So that last one is 5. The one with t is positive 60. And it's negative 16t squared. And just so that you know, when you get into physics, you'll learn why it's negative 16. That's got to do with gravity, but you don't need that for algebra 1. All right, so that's my graph. So there it is, graph. So use graphing technology to graph that. So I'm just going to make this a little bit bigger. All right, so if I was graphing it, I'll put it right here. The distance of 5, it goes up and comes down. And then you're going to obviously label like what all these things are. So this one right here is 5. And we're going to find out what the vertex is and what the seconds is, I'm sure, with the questions. All right, so there's my graph, and I'm going to label it accordingly as I do it. So it says, observe the graph and describe the shape of the graph. What does that tell us about the movement of the cannonball? All right, so go ahead and describe the shape of the graph. So there's no wrong answers, just what do you see? Okay, so what does the shape look like? All right, so it's a quadratic. It's shaped in like an N. So it's a downward facing quadratic. What does it tell us about the movement of the cannonball? Something along the lines of it goes up and then goes down, something like that. All right, so again, I'm not writing those down, so I'm just speaking it. So go ahead and rewind the video if you're not hearing what I'm saying so that you can hear me. So describe the shape of the graph. It's a downward facing quadratic. What does it tell us about the movement of the cannonball? The cannonball goes up and then comes down. Estimate the maximum height the ball reaches, and when does that happen? Okay, so the maximum height. So we're going to go ahead and find the number over here. So I'm going to label both on my graph. All right, so I come to my calculator, click in here, and then go and put your mouse there. So the height is 61.25. So then I'm going to come label it right here, 61.25. And this is in feet, I believe. Doesn't tell me actually. Oh yeah, it does right here in feet. So estimate the maximum height the cannonball goes. So it's going to be 61.25 feet. And when does it reach that? So the X value is 1.875. All right, so over here is 1.875. All right, and I will take 1.875 is like 1.9 seconds. Estimate when the ball hits the ground. So looking right here, put it right there. So it hits the ground at 3.832. So go ahead and put that on your label, and obviously please write a little bit neater than me. 3.8, I forgot the rest of the numbers. 3.832. All right, so estimate when it hits the ground around 3.8 seconds. What domain is appropriate? So remember when we're talking about domain, right? It's all your X values where there's a graph. Now there's a graph on the negative side as well, but it doesn't make sense in real life situation because when the ball goes up and comes down, when it hits the ground, it does like a little motion to where it doesn't go inside the ground, like it'll bounce like this, right? Like something like that. All right, so domain is really the positive value. So I can see right here that from 0 to this point here, 3.832, there is a graph. Because if you look up here, there's a graph. So your answer would really be that 3.82. So from 0 to 3.82, and which we're rounding to 3.9. Now, when you have to explain your reasoning, you're going to say that. You're going to say, even though a graph exists on the negative side, it doesn't make sense for time to be negative. You can't have negative time. So when you explain your reasoning, just say you can't have negative time. Therefore, the domain is from 0 to 3.9. So I'll say it again. You're writing it down because I'm not going to write it down because it's going to look really bad. I'm saying it again. Just write down what I'm saying. So what domain is appropriate for that function? 0 to 3.9. Explain your reasoning. Since you cannot have negative time, domain must start at 0 and end when the ball hits the ground at 3.9. Okay, and that's pretty much all there is to it. So word problems are all about just drawing the picture, right? And then using the calculator to do it, or you can use it by hand, just whatever your preference are.